So in this discussion, we will see whether precipitation will take place or not. So we are given this question. In a precipitation reaction, a student took 400 ml. A student took 400 ml of 0.004 molar barium chloride and added exactly 600 ml of 0.008 molar potassium sulfate. Determine whether precipitation will occur. KSP for barium sulfate is 1.1 times 10 power negative 10. So here we are given the KSP, solubility product constant, and we need to know, or we need to identify whether precipitation will occur in this reaction or not. So if the ionic product is greater than the KSP, that is solubility product constant, that means there is precipitation that is taking place. And if the ionic product is less than, the value of ionic product is less than the KSP, that means there is no precipitation that is taking place. So first we write the equation between barium chloride and potassium sulfate. So solution. So we'll first write the equation. Potassium sulfate plus barium chloride forms potassium chloride, plus barium sulfate. So, and then we write the ionic equation of that reaction. The ionic equation will be barium ion plus sulfate ion barium sulfate, so solid. Okay, now from there, now that we have got our ionic equation, we need to identify the final concentration of barium ion and the final concentration of potassium ion. We have got the initial concentration of barium ion, that is 0.004 molar, and we have got the initial volume of barium ion, that is 400 ml, and we have got also the final volume of barium ion, that is 400 plus 600, which is 1000. So to get now the final concentration of barium ion, so here we have got initial concentration of barium ion. Initial concentration of barium ion is 0.004. Initial volume of barium ion, we have got 400 ml. That will change to liter. It will be 0.4 liter, and final volume of barium ion is 400 plus 600, that will be 1000 ml. Change to liter, that will be 1 liter. So we need now to find the final concentration of barium ion. Final concentration of barium ion. So to get the final concentration of barium ion, we will be using the formula M1 times V1 is equal to M F times VF. That is the initial concentration times the initial volume is equal to the final concentration times the final volume. So for us now to get the final concentration, we divide the value volume, final volume. So that will be M, if that is the final concentration of barium ion, is equal to the initial concentration times initial volume all over final volume, that is. So the initial concentration we have 0.004. So final concentration of barium ion will be barium ion is equal to initial concentration, which is 0.004, times initial volume, which is 0.4, all over the final volume, that is 1 all over 1. That will give us, that is equal to 0.004 times 0.4 over 1 is equal to 0.0016. So this is the final concentration of barium ion. Okay, again we need to identify the final concentration of barium sulfate, that is final concentration of barium ion will be, since we have got the initial concentration of, sulfate ion, 0.008 molar, we have got the initial volume of sulfate ion, which is 600 ml, and we have got the final volume of sulfate ion, which is 600 plus 400, which will give us 1000 ml. So initial concentration of sulfate ion is equal to, we have got 0.008 molar. The initial volume is equal to 600 ml. To change 1000, that will be 0.6 liter. And final volume is equal to 600 plus 400, which is 1000 over 1000, change to liter, which is 1 liter. So now we have got the initial concentration, the initial volume, and the final volume. So we can get the final concentration. So to get the final concentration, MF is equal to the initial volume concentration, which is 0.008, times the final, the initial volume, which is 0.6 liter, all over 1 liter, which is the final concentration. So that will give us 0.008 times 0.6 over 1 will give us 0.00448 molar. So that is the final concentration of barium ion. So KSP, the ionic product of barium sulfate is equal to ionic product of, that is Q ionic product of barium sulfate is equal to the molar concentration of barium ion, which is 0. Before that is the molar concentration of barium ion times the molar concentration of sulfate ion. So the molar concentration of barium ion, we have got 0.016. So that is 0.0016 times the molar concentration of sulfate ion, which is 0.0048. So that will give us 0.0048 times 0.0016. So that is equal to 7.7 times 10 power negative 6. So that is the ionic product of barium sulfate. Okay, since now we have got the ionic product of barium sulfate, we compare the ionic product of barium sulfate and the KSP, that is solubility product constant for barium sulfate, which is 1.1 times 10 to the power negative 10. So if we say if the ionic product is greater than the KSP, that means there is precipitation that is taking place. And if the ionic product is less than the KSP, that means there is no precipitation. So our value of the ionic product is 7.7 times 10 to the negative 6. And the KSP is 1.1 times 10 power negative 10, which means between these two values, 7.7 times 10 power negative 6 is greater than 1.1 times 10 power negative 10, which means the ionic product is greater than the KSP, that is solubility product constant, and therefore there is precipitation that is taking place in this reaction.